Hello, I'm Lila. We're here at Barrick Cortez in Northeastern Nevada, and we're here to find out how modern gold mining works. We've been granted full access here, and we're going to take you around and talk to the men and women who make this mine work. We chose Cortez because of its size. It's got 2 surface operations, a big processing facility, and an underground mine. I've never been to anywhere like this. Why don't you join me and we'll find out how modern gold mining really works. What strikes you first here is the size and scale of this operation. From the 400-ton haul trucks to the massive P&H shovels, it's really quite impressive. You take a look into that open pit and you'll see what I mean. Think of the design and the engineering that go into creating something like this. These people really know what they're doing. And then you go thousands of feet deep into the earth to the underground operation. And you realize that this is not the good old days of panning for gold. In fact, the gold that they mine here isn't even visible to the naked eye. It's called microgold, and they mine thousands of ounces of it each year.
So let's begin our journey of Cortez here at the underground operations. Though underground mining is way more expensive to do than surface mining, the extra costs associated with this method are offset by the much higher number of ounces per ton of gold retrieved. Mining methods vary with each underground operation and are dictated by the characteristics of the ore body itself and the most cost-effective means to extract it. Here at Cortez, the underground operation is accessed by twin declines portaled in the old Cortez Gold F Canyon pit. These parallel declines each measure 16 feet wide by 18 feet tall and extend for nearly 2 miles into the earth to access the rich gold deposit. They're used to haul ore out and backfill in, provide ventilation to the mine, plus they aid in the dewatering of the Cortez Hills open pit mine, which is directly overhead of where the underground mining is taking place. In fact, the top cut of the underground operations will eventually be the bottom bench of the surface pit.
But before any of this can happen, it takes a highly skilled team of geologists and engineers to come up with the mining plan. Their plan maximizes both the safety and the profitability of this mine. Before we go underground, let's go talk to some of them.
Cortez Hills Underground is what we call cut and fill mining. It's an entirely mechanical method, and we go through and we drive a tunnel and we backfill it with a cemented backfill, which looks a lot like the concrete that you drive on every day or your house or your office is constructed out of. And once we've gone through and mined it and backfilled, we then go back underneath that fill again and drive another tunnel. Kind of get a bit of an animation here, and you can see where we're at right now as we're working on one of the undercuts, and you can see where we've got 3 levels above us that we've mined out and where we've gone back in underneath, and here's another level developing here. And so the orange is the access that we drive, and the green is when we start mining underneath the backfill, and you can see how the green bars line up with the green bars above, so that we always have that cemented rock above our head, and that's what we're working on. One way to think about it is it's essentially like playing Jenga with a vise, where each one of these cuts is the individual block in the Jenga game, and the vise is simply the pressure from the rock, the mine itself, holding everything together. And we're going through and we're knocking out individual blocks, and then we're pushing another one back in. And then we just work our way down through the mine that way, pushing out a block and filling it back in. The geologists kind of put together where it is and what's going on. The engineers put together the roadmap on how we're going to get there and what we're going to do. And survey issues the driving directions. And they actually go down and set up the control, the lasers. We actually have a laser that the survey puts in and shows the guys where to go with the directions to mine. And altogether there's about 40 people at Cortez that's their role, between the geologists, the engineers, and the surveyors. You know, as a technical services group, our goal at the end of the day is to design the safest, most economical mine possible.
Welcome to to the beginning of the mine cycle. This crazy looking machine behind me is called a jumbo. Its job is to drill 1 7/8 inch holes 6 to 10 feet deep into the face of the heading. This used to be done by a jack leg drill and a lot of sweat and a lot of muscle. Now the jumbo takes care of that. It's a lot faster and a heck of a lot safer.
So this is a DD420 two-boom drill. After they come in and bolt up, put up all the ground support, I'll come into the heading. I usually park back out by the beginning of the heading, walk down and check for any substandard conditions and get all those fixed. Then I'll bring the jumbo down after I paint up my grid and start to drill. So we got a lot of different patterns. We don't drill anything more than 3-foot centers. So I'll go off the cut sheet. It'll have left, right, down, and up, and a grade percentage up or down. I'll paint all that up, and then I'll come in and drill right on the cross lines all the way across. They're 1 7/8 holes. I'll drill from 6 foot to 10 foot, and then we'll put a burn in it, which can be 6 to 9 holes. It's just to start the round, to initiate it. This one's 25 wide. With both booms, take about 1 hour and 45 minutes to 2 hours, depending on the rock, if it's hard or soft, sluggy or not. This one's pretty soft, so it'll take a little longer, about 2.5 hours. So this is all cut and fill in here. So we got backfill up in the back and on the left rib. We're going next to the last cut and under the last level. Backfill's really safe. It's stronger than the rock itself. I'm in an enclosed cab with air conditioning and keeps me out of the dust and the heat and away from the elements. I love the job. I take a lot of pride in what I do. Every round that I shoot, I like to come look at it and make sure it come out nice and see the kind of changes I can make. I've learned a lot everywhere I've been.
Okay, so the jumbo comes in and drills the hole in the rock. And then the powder crew comes in and they put the explosives into the holes that have been drilled. It's an amazing process. They do it in a pattern, so a hole blows and then others blow around it, and then it blows down and then it blows up. This way, the muck trucks can come in and scoop it up and drive right out. The thing you gotta know about the powder crew is that they're highly trained. They think about safety first, and then they think about safety some more. Let's go talk to them.
Well, you come in, you time out the round. It starts with the caps, and they start at 1, and then they go up to 19, and then you start with the burn. You time out the burn real slow so you can break the burn, and then you break everything to it. So you like sandwich it in, you bring it all down to shoot the round out. You break it slow, you break from the middle, and then you break it in, from the middle in, and then you hit your lifters and it fluffs up the nut pile and sets it down. We load with emulsion, so to set emulsion off, you gotta put a booster on the end of your cap, then we stick it into a hose, shove it in the face, fill up the hole, leave a 2-foot collar, tie it all in with det cord. Then the det cord gets tied in to the icon, and the icon reads to our computer system, and bang.
So after the blast is detonated electronically from the surface, when the mine is evacuated at shift change, the next phase of the underground mine cycle is ready to begin. This process is referred to as the mucking and trucking cycle. It was a little bit too loud to talk on camera at the time, so let me now explain how this all works. It's like a well-choreographed dance routine. The 6-yard mucker scoops up the fractured ore from the headings and carefully loads a fleet of 30-ton haul trucks, all within this very tight area. The men and women who operate this equipment are very skilled operators who safely jockey this very large equipment around with precision so as not to damage the ventilation, electrical, and water systems which run overhead. Throughout the mine, numerous headings are being worked on simultaneously, providing a steady stream of ore on a daily basis. Once loaded, the trucks wind their way to the surface, following miles of tunnels to the main decline as they head for the ore stockpiles. Let's meet some of the operators who do this on a daily basis.
What I'm doing right now, I'm mucking out a heading. I'm mucking up a 45-35 down here, and just in preparation for cycling the round. After the blast, after the shot's taken, mucker comes in, mucks out the muck. Next piece of equipment in will be the bolter, and then the jumbo. They'll drill it, load it, shoot it again, and just keep mining our way on back into the ore body. A day we can load between 50 and 70 loads of muck out per shift. This one's probably going to take like an hour and a half to get it mucked out and get it loaded out, maybe 2 hours. Between the 6-yard muckers, we run an 80-30 haul truck. We're hauling between 25 and 30 ton out per load. We're running typically between 6 and 9 trucks per rotation. Each truck's probably getting between 15 and 20 loads per rotation out. It's a lot of muck gets hauled out, plus our backfill that comes back into the headings after they're mined out for our ground support. So yeah, there's a lot of material being moved. It's not like the old days. That's pretty cool. Yeah, this thing's pretty awesome. It's a big, mean machine, you know, but it'll flat do the job.
This is your underground haul truck. It's a Cat AD30 and 30-ton truck hauling the ore out. Take it straight up to surface, and depending on whether we're hauling out ore or if we're hauling out waste, we take it to whatever designated pile up there on surface, turn around and come back down to get more ore. Or if we're backfilling, we'll stop at the backfill plant and pick up some backfill from there and bring it down. It might be only 15 a day or so, but sometimes we can get up to 21, 22 loads a day. Lots of going in circles. A definite learning experience. There's always something going on, so it's a constant watching your surroundings and making sure what your fellow coworkers are doing, and it's interesting. It's a whole new world, so, but fun. I like it.
Proper ground control is the key to underground mining. This machine behind me is called a bolter. The side of this is called the rib. The top is called the back. Now, what these guys do is they come in and they put a sheet of steel mesh across the rib. And then they take a high-tech bolt called a Swellex bolt and they drive it into the side of the rib to hold the mesh on it. Then they take water that's highly pressurized and they drive it into that bolt. The bolt expands and holds. These bolts are so strong that they can hold up to 12 tons per square foot.
Simple way of explaining it is, if you took an apple and you chopped it up into chunks and you set it on the table and you let go of that apple, it'd just fall apart. If you took that apple, chopped it up into chunks, but then you drove toothpicks or skewers through the apple and set it on the table, that would hold the apple together. So essentially, that's very simplified. That's what we're doing with our ground support. We're pinning the rock together using the friction bolts, creating a ring of compression so that as the stress flows through the rock, it goes around the tunnel, keeps the tunnel open, keeps the drift open and safe for the miner. Shotcreting's kind of dual purpose. It does a few things for us. One of the first things it does is it's added ground support. So as the shotcrete, which is just another concrete mixture, sets up, it makes a hard shell that stops any of the littler stuff that might fall through the wire and come down and injure anybody. The next thing that it does is it creates a seal. So as you're mining through the rock and you seal it with shotcrete, it keeps the rock from drying out and fracturing any further, what we call air slacking. And then another thing that the shotcrete does for us is it gives us a visual aid. If any of the ground starts to move, we can see the shotcrete crack, and it gives us an indication of what the ground's doing, or if we need to come back and install more ground support.
Obtaining the proper ventilation underground is truly a science unto itself. Maintaining a safe work environment thousands of feet below the surface is further complicated when you operate massive diesel-powered mining equipment in very confined spaces. To address these issues, a team of engineers and safety and health specialists design and constantly monitor the climate created deep within the earth so mining can move forward.
Well, this is considered hard rock mining. Coal mining, often they emit gases such as methane, and that's why they have readers at their cutters and everything underground. Here though, at this mine, we don't have any gases that come from the rock. So our main concerns are from blasting fumes, which happened at the end of shift to mitigate those. And also, we don't even allow the miners back underground until 30 minutes after a blast. So right now, all our equipment underground is diesel, and we use a red dye biodiesel. And that's because, one, it emits lower DPM. The other reason why we only use diesel underground is gasoline has a lot more toxic gases that it can emit. So currently, with the way our ventilation is set up and our mine is set up, we have twin declines, the west and the east. On the west, there is 2 main fans that are capable of blowing hundreds of thousands of CFM underground. That would be considered the primary ventilation. So from there would be the secondary, and that would be from vent raises, and then to get into the levels, right here connected to the ends of the 2 hard lines are 2 200 horsepower fans. And that provides enough air to not only enter the heading safely, but also to run equipment safely. There are various ways to monitor. One thing is the ventilation engineers will come down and take vent readings of headings, levels, main accesses, and create a ventilation model on the computer. And that way they can calculate differences in pressures, what certain vents would happen, and what the results would be. You have to have a certain amount to be able to run certain pieces of equipment. Once that's established, what the safety and health, industrial health people will do is there's actually monitors that they'll give to various miners and personnel underground that will take values of different, DPM, dust, and other elemental vapors that could be encountered underground. And they'll measure that against a baseline to not only monitor how the air is underground, but also monitor the health of the employees.
Like I said at the top of the show, these are not the good old days of panning for gold. And the horror stories that we've all heard of old-time mining techniques and worker safety are a thing of the past as well. Today, the safety and well-being of all the employees and contractors who work at Cortez takes priority over production. And it was very cool to find out that anyone, even me, could shut down a job if they felt it was unsafe. Trust me, these folks definitely take safety seriously.
Oh, it's totally different from when I started back in the 70s. Safety now is so prevalent in, with the companies, where years ago it was muck, bolt, drill, blast, and you better make that round every day, otherwise you weren't in those headings anymore. They brought somebody in that could cycle them. Now, our main issue is safety, and then production follows that. Of course, now it's all mechanized. You're not having to use the jack legs and like we did years ago. It's not near as physical as what it used to be. And the ventilation is by far superior to what it used to be. I mean, you used to go in and you'd muck out and you couldn't even hardly see the face by the time you get done mucking out. It's not that way anymore. Our contracts are mine-wide, have X amount of footage for the month that's planned out that we could achieve, and everything without, having to cut corners to achieve our goals. And everybody can work safe and everything else. You don't have to be on a dead run from the start to the finish of the day. So it's a lot more controlled than it used to be, where the more you broke, the more you made. Here we have X amount of footage per month that we need to get out, and that's what we strive to do.
Now that we know how the underground operation works, let's go topside to explore the massive open pit operations at Cortez and meet the people who make it all happen. Welcome to the open pit operations at Cortez. Currently, there are two very large surface operations underway. The original pipeline pit complex, and on the other side of the Crescent Valley is the new Cortez Hills operation. Each one of these open pit mines employs the same basic method of ore extraction as the underground operation: drilling, blasting, then mucking and trucking. But the size and scale to which it is carried out is really impressive. They utilize some of the largest earth-moving equipment in the world and move an average of 500,000 tons of material per day. And similar to underground mining, ground control is also very important. The massive open pits are designed and constantly monitored to ensure the stability of the high walls and the safety and well-being of those who work here.
The way we make the high wall safe starts from the beginning, before mining, when we drill a couple of holes and we analyze the rock coming from those drill holes. Depending on the rock mass, the type of structure we intersect, we're gonna design the outer pit basically with a certain angle, compared to the north, a certain width of the benches and height of the benches. Once we start the mining, we're gonna install on each benches a couple of instruments for us to monitor the movement of that wall. Basically, it's prisms, so that they are mirror that a laser is gonna shoot, and basically depending on the distance from the radar of that mirror, the radar is gonna send in an alarm saying the wall is moving or not. The one I have behind me is basically scanning the entire wall every 10-20 minutes. It gives us a movement of the high wall in real time, and we can connect to it in our office and see it right away. And we also walk constantly all around the wall to make sure we visually have a monitoring.
So with the mine plan in place and the safety concerns addressed, let's see what it takes to mine this microgold on such a large scale.
Welcome to the first phase of the mine cycle. This is where it all begins. Drilling.
Pit is designed, we have geologists and modelers that take exploration drill holes and they model the ore body to figure out where the ore is spatially. And it's somewhat of an estimate, it's pretty good, but when we get into mining, we have to drill to blast the rock, and that's on a much tighter spacing than the exploration holes. So we take the cuttings from the drill holes for the blast holes, and we have them assayed and sampled for the gold.
And do you guys have an on-site lab that you do that with?
Yes, we do it on site. I believe we do somewhere in the neighborhood of 400 assays a day, and it gives us much better definition of the ore body just before we mine it.
Shots 1 and 2 have fired.
This is the next phase of the mining cycle. We're with the blasting crew. What they do is take this and turn it into this. I would just suppose that using explosive, it's all about the control and the safety and the finesse of finding the right amount of blasting material. How far do you punch the hole in?
We dig 40-foot benches. We do, on occasion, we've done some odd number benches, but generally a 40-foot bench is what we go after with 4 foot of sub-drill.
What's sub-drill?
The drill will go out on the pattern, and he knows he needs a 40-foot bench. If it's high, it'll tell him to drill like 46-foot hole because they're 2 foot high. So he's gonna always have extra footage from the sub-drill, and then he's always gonna know his location. You know, if say he's above grade or below grade, it'll tell him, and he'll drill it to grade plus 4 foot of sub-drill. And that's something we use to help achieve the proper fragmentation so the shovel can dig it. So they can get the floor out and everything goes smooth.
Now, when we see the explosion go off, it doesn't go up, it goes across, right?
Well, I'm not gonna say it never goes up.
Right.
That, you know, where does energy wanna go? It's going to take the path least resistance,
Right.
and up is generally something, but we try to control that. So we don't want that. We want that to be completely confined in the ground. So if you watch a shot that we are proud of, they just roll. It'll actually just roll, and there's nothing ejected out the top. And that's what we want to achieve every time.
And that's breaking up the material.
Right.
We're watching it blow the material
inside.
And it's not just the explosion that breaks. There's a lot of gas and a lot of pressure, and that rolling, heaving process is shearing and breaking the rock too. It's not just the actual bang that breaks the rock, it's that heave and roll.
Now, what's the material that you use as the explosive?
We use a cap booster for initiation, and then we use AMFO, which is ammonium nitrate and fuel oil. And at the blast pattern, they are mixed, but not before that. When they're in transportation or storage, they're always separated, and then when we come out to the pattern, it mixes on the truck as it's feeding the hole.
Right on site.
And it's a prescribed percentage of fuel that we use that mixes with it. You get too much fuel or too little fuel, you can have problems too. So we want to, there's like, it doesn't sound like rocket science, but there is a fine line to make sure everything's done right.
Like rocket
there's
science.
There's a lot of detail that you have to cover.
So you fill the hole, and then you put something on top of it so it doesn't blow straight up. What is that?
Stemming material that's around the hole. Call for stemming material if we need to, but it goes in and fills the hole up all the way to the top of the collar. And what that does is it gives it basically a plug. So when that, from the confinement, the AN, the AMFO initiates, and it doesn't eject out the top. That way it allows it to, all that energy to go out and break everything. There's a lot of seismic activity that occurs when a shot goes off. And you want to try to achieve the least amount of disturbance as possible. And the right amount of, you're going to have some regardless, but you want to control it. Again, everything's
about control.
Everything's about control. You don't want to let it get away from you.
Super.
Firing shots 1, 2, and 3 in South Gap. Okay. Now it's you.
Okay.
Both at the same time.
Checking.
Okay.
Firing. Up.
Watch this one. Now watch the big one.
Yeah. Oh my God.
Now watch this one.
Yeah. That's amazing.
Shots 1, 2, and 3 have fired. Good job, guys.
Yeah. Awesome.
Good job. Boy. Good job. And you get all the credit.
Oh yeah, all of the credit. So you thought the blast was cool that we just did? We're standing now in the open pit, and we're over with the 400-ton trucks. This is one of them right here. Each one of these 400-ton trucks, they get about 4 or 5 buckets dumped in them, and then they go. To give you an idea of the weight of the ore in that one bucket that's going right now, a semi-truck that you pass on the highways, the weight of 3 of those is in one of those buckets. The guy named Corey that's sitting in that cab is responsible for digging out the ore and moving it toward these 400-ton trucks. The amount of soil that this bucket moves is incredible. When you're in there, you're right up next to it, and the sensation of it is incredible. Why don't we go meet Corey? We should go stand in that cab. Let's go.
The technology has gotten better.
Yeah.
And the trucks are bigger, shovels are bigger.
Yeah.
So you're able to produce more tons moved at the end of the day.
And how many tons in a scoop? We just scooped up how much?
This bucket, I think, is, I'm going to say 50 or more tons. If I remember right. The bigger ones, I think, are 70 plus,
yeah,
I believe. You can hit 200 loads with this shovel in a 12-hour shift.
Yeah.
It's doable.
Wow.
The big shovels, I think one of our guys, he got 290 loads so far on that. That's a lot of loads for the day.
Right.
That's just one digging unit.
And I'm sure for you guys, it's not about how fast you go, but how safe and how effective and how efficiently you scoop.
Yeah, you're getting all these loads, and then towards the end you hurt somebody or damage equipment. Then it's
counterproductive.
Yeah, we want to have a good safe shift. And for me, it's not going fast. It's just being efficient.
Right.
So if I'm filling this bucket every time, I don't have to go fast. And
right. You don't have to be speedy.
Yeah. Fill the bucket every time, and you're being efficient.
just the sheer volume of ore to the
ounces per ton.
Yeah, ounces per ton.
Yeah.
And it blew my mind how much is made. And I understood fairly quickly why the investment, because the return on it is amazing.
And that's where the computers come in for. That's the part I like, because if you need to make sure that ore goes to the right area for recovery.
Right.
And with the GC and me giving the assignments, it's a for sure thing that ore gets to the right spot.
As you can imagine, the proper training of the employees who operate this huge earth-moving equipment is vital to the safety and success of this operation. When you have a 3-story tall shovel feeding a 2-story high truck, everyone needs to be on the same page and know exactly what they're doing. We were invited into one of the simulators used to train the truck drivers who operate this equipment in all kinds of weather and conditions.
So this is actually, you're in constant physical contact, even though it doesn't feel like you're moving very quickly. You have to be really physically aware of what you're doing.
Correct. Because you are in about a 3-story house. Right?
Yeah. Okay, so what's going on with me now?
So once we get to this intersection, we'll make a right and we'll go up to that shovel.
Okay.
Harder. There you go.
All right.
And then kind of angle this way a little bit. Keep going, and we want to, now make the turn. We want to put this little arm right on our bed rail. See that little arm? So let's go ahead and put it in reverse.
And that's back?
Yep.
All right.
And then as we back up, we'll try and get this bed rail right on that arm.
Okay. Did I do that right? Do you have to honk 3 times to go past?
When we're in production, that's the correct horn signal, but in production you don't have to use horns.
Oh, okay.
So
now
go ahead
in
back
reverse,
up.
and it tells me in reverse.
Once again, it's going to take a little bit to get it rolling and try and keep it rolling. But stay under control so we can stop when we want to. Good. Angle your bed rail over to them. That's the right. Yep, keep going that way. Get it over there. Get it over there. There you go. Perfect. Keep going. A little bit more. A little bit more. A little more. A little bit more. And then stop braking.
What, dear?
Go ahead and stop braking. So we drifted a little bit. Let's pull up just a hair.
Okay.
We want this so we're looking straight down it.
Okay.
The button over there. There you go.
The second
Next one. There you go.
All right.
Look at that. That's pretty good.
All right.
Shows your position under the shovel.
Awesome. Okay.
So that's actually very, very good.
Yeah.
Really good.
Yay! Can I have a job?
Now you can let it off.
All right.
So we do class time. We do sites tours. We take them out on tours. We'll do walk-arounds. We got training grounds out there that we like to take them to the training grounds. Just let them drive around out of production, and then at least a week of stuff inside the simulator.
Wow.
Things inside the simulator will be an introduction, just kind of what you just got.
Yeah.
Just to make sure they feel okay in here. Sometimes this makes people a little bit queasy.
Yeah.
And then we'll go right straight to spotting at the shovel, at the dump, and then emergency procedures.
Right.
Here, which is kind of our final test.
Right.
We just set them on fire time and time again, just to make sure that they can get out of it.
Now you're on fire. Ah! God.
Yeah, pretty much.
Thank you so much.
No
really
problem.
appreciate it. That was
No
great
problem.
fun.
So what does it take to operate one of these supersized trucks? It takes women and men with the right attitude and skill set to respect the capabilities of their equipment and each other. This deep-rooted safety culture in place at these facilities is paramount to ensure everyone goes home safe and healthy every day.
Well, my average day is I want to be better than the next guy. and that keeps a lot of us going. Oh, he just made that load. I got to get in there and get that load. But as long as you do it safe.
Right.
It's not a racing thing, but it's a keeping up thing, you know. We call ourselves the Thundercats, the rolling Thundercats, you know. And we be rolling, but we staying safe. I think the training got a lot to do with it.
Yeah.
They can see what you're going to be in your training.
Right.
And if you keep something up, then it's an issue. Then they could just about tell what's going to happen by the habits that you have in messing up, you know?
They can track it.
In your training, you develop another aspect of driving. You take on a seriousness, you take on a sense of caring and everything like that, because that's what they put into their training. I've never seen safety like they have here. I've never seen it, because they have you to take it home. Yes, I like the safety culture, because every morning they ask, did anybody have a safety share? You know, and that's really awesome. And sometimes I'd say some things. And when something happens, you put it down on your FLRA card and things like that, and you can talk it over with anyone in safety and anything like that. They give you so many hours of safety and things about every little thing, and that you can think of, because it's needed. Because once you start sliding and didn't ask about it, then you're out of control. You're no longer in control. But when you're in control is when you're ahead of it. And you want to be ahead of those things, you know? And that's what I've learned in driving, being used to driving, that you have to do. You have to stay in control.
So now that we understand how they mine here, let's step back and take a look at why they mine here. Once again, the gold throughout much of northern Nevada is microgold that is not even visible to the naked eye. So how do they know where to find it? To answer this question, we spoke with one of the many geologists on staff whose job it is to not only discover new resources, but maximize the production from those being mined.
So we're standing almost at the bottom of a pit that was mined, right? This isn't active any longer?
Correct. Yeah, we just finished this a couple months ago.
And how long were people working down here?
This pit started about in 2008.
We're looking at about 5 or 7 years here.
Yep. And it'll be active again in a couple more, probably next year as the next phase comes down.
Could you tell me how this was formed? What kind of rock we're looking at?
Oh yeah. All right. So very long story, of course, and I'll try and sum it up. So basically all the rocks you're seeing here, the background, excluding the white ones that you see going up, those were all formed at a continental slope under the ocean. So they're primarily limestones, siltstones. Sometimes you find some fossils of ancient life forms that lived in this ocean. And those were all formed, and then they were folded and faulted through a series of mountain building events. And then later we had these much younger rocks, which are the white ones, and those are a type of magma that actually came up and squirted through fractures or faults in the rocks. And they make our dikes that you see on the walls.
When you are looking for gold in the mountain, what do you look for? What kind of formations are you looking for, or colors? I mean, how do you find it?
Well, that's really tricky actually, and that's kind of a million-dollar question. A lot of times you do a lot of drill testing, you do some chemical tests with the soil. That's more the exploration area. And then once you actually get into it, it's a matter of drill testing and assaying and then doing a geologic model to try and find any trends in the deposit, because each deposit's a little bit different. So there's no set key of how to find gold. For us, our main deposit in this pit is actually seen in this wall, and it's the breccia pipe. And so that was something that once they found it, it was a matter of actually just tracing where that fell. And that was kind of our high-grade body that we could follow. And I mean, to set the conditions right for this type of deposit, it takes, billions of years and many different episodes, and no one's really sure the exact combination. So we had, starting about 1 billion years ago, so really old structures and faults just happened to set up and condition this area to then be a good candidate for holding gold, and plus, folding and more faulting, and you have to have the right rocks to trap the fluids in and concentrate the gold. So it's a long and complicated process that we're still studying it every day, trying to figure out why exactly this spot do we have gold.
Now I have a question. We were talking about veins of gold, That's a different thing than what we see here, right?
Yeah, that's not something you're going to see in this mine. So all the gold in this mine is disseminated gold, unfortunately. So it's all distributed within the actual rocks themselves, and so you actually have to dissolve the rocks to get the gold out. In the breccia body itself, I mean, you can get upwards, we had a very small hit of 8 ounces per ton. Wow. So, but that's really unusual. Right. So a lot of times you get a lot lower than that, you know, a couple ounces per gold, and that's considered pretty high grade for an open pit.
With the ore now mined from both the underground operation and the larger open pits, the process of retrieving the microgold can begin. At Cortez, this process is dictated by the ounces per ton contained in the ore they mined. The lower grade ore is hauled directly to a heap leach pad facility. This process works by stacking the ore on an engineered pad that is lined with a thick, impermeable plastic liner. A dilute cyanide solution is then applied to the ore by a series of drip lines. As the cyanide trickles down through the material, it dissolves the gold and carries it to a lined collection pond. From here, it's pumped through a series of carbon columns that captures the gold as it bonds to the carbon for further processing. For the higher grade ore they mine, the process is much more complex.
Now we're at the crusher. This is where the open pit operation ends and the processing begins. Over here are stockpiles of ore. They're selectively graded and then fed into the crusher. Let's go inside and see how it all works.
The crusher circuit at Cortez is really amazing. This huge gyro can reduce a large boulder down to football-sized rocks in a matter of seconds. And this entire facility is computer-controlled by just one operator. The selection of the stockpiled ore being fed into the crusher is based upon what grade and ore type is being called for by the mill for processing.
Down below us is the conveyor. The crusher crushes the ore and drops it onto that and takes it 7 miles across the valley. This is an amazing engineering feat. That can take 1,000 tons of ore across that valley in 1 hour. 7 miles later and about an hour, the ore has traveled all the way across the valley, and so have we. Behind me is the mill, and that's where the ore goes next. I'm standing here with Les. Les, what do you do here?
Well, I'm a mill supervisor here, and behind us is our final transfer tower from across the valley. The ore drops into there onto our stacker belt, travels to our crushed ore stockpile, and from there it feeds out the bottom on apron feeders to our number 3 belt, which you see going into the mill.
I see. So what happens to the ore after it goes into the mill?
It runs into a sag mill.
What's a sag mill?
A sag mill is a semi-autogenous grind.
There we go. A semi-autogenous grind. I love it.
We have 5-inch steel balls inside the sag mill that break the ore down and release it about 3-inch minus. And from there it goes into our ball mill, a secondary mill. When it comes out of there, it's about 70% passing 200 mesh. It's a very fine, just a fine powder. And it goes into a grind thickener after that, and we lower the slurry, the heavies, the ore, to the bottom, and your clear water comes to the top.
I see.
From there we separate it. The slurry goes out the bottom and comes up to our CIL tanks, which you'll see here. We add cyanide in our surge tank to start the reaction of dissolving gold.
Right.
And from there it goes into our CIL tanks, carbon and leach, and there's carbon in there, and the gold gets absorbed into the carbon.
You put the gold into the solution, and then you run the solution through carbon. How does the carbon grab it, and what's the carbon on? I want to see it in my mind.
Well, if you've seen carbon in a microscope, it looks like a sponge. It's very porous.
Right.
And with gold dissolved into solution, it gets absorbed into the pores of carbon. So as it goes through the CIL tanks, the first 3 tanks, we've picked up almost all the gold into carbon.
And then where does the carbon go that's loaded with the gold?
The carbon gets, if you look at the tanks, we rotate our carbon and gets moved up the train as it goes. So our barren carbon is in the lower train, our preg carbon is in the higher train. We pull the carbon out, pump it out over a screen and separate it from the slurry.
Right.
From there it goes down into our elution circuit.
Oh, okay. What's an elution circuit?
Our elution circuit is our strip circuit.
Uh-huh.
From there we'll put the carbon in strip vessels, and we heat the vessels up with a barren solution to about 275 degrees at 80 psi, and it presses the gold out of the carbon back into a solution.
Nice. And where does the gold go after that?
The solution goes into a preg tank in our refinery. From there, we pump it through electrowinning cells. Electrowinning cells are basically a positive and negative charge. The gold gets collected onto the anodes.
Wow.
And from there, it's a sludge, gold sludge. From there, we press it down to a cake and melt it down to gold.
Now, you say cyanide, which for me and people who don't know about how chemicals are used and how you use them so they're not toxic, that's like cyanide. What can you tell us about that process so we know that you're safe and that we're safe?
Well, cyanide can be deadly, and you have to respect it. We run about a 1/4 pound per ton of solution of cyanide. To put that in perspective, you'd have to drink about 3 gallons of the solution to really see any effects. I don't think it can hurt you that way, you know, but we do have it in a higher concentrate around here, and absolutely, you have to respect it. We have a cyanide code out here that Barrick adheres to. It's an international code, and they're very strict on your uses of cyanide, how you handle cyanide, and how it looks throughout the industry. Signage, warnings, everything about cyanide is handled through that code, and we're very proud that we've accomplished that, passing the cyanide code.
Terrific.
A gold pour is just about ready to happen. Let's go check out the final step in the gold extraction process. The furnace here in the Cortez refinery is a hot one. It's cooking this gold to 2,000 degrees Fahrenheit to remove any impurities. Once this is completed, the unwanted slag is removed from the top of the molten gold, and then they take a sample for assaying purposes. The molten gold is poured into bars, and they contain about 90 to 94% gold and 3 to 6% silver. The bars are then cooled down and are sandblasted to remove the slag. The bars are then assigned a number, and then they're weighed and logged. The gold bars are now ready for storage in the safe until they're transported off-site for further refining down to 99.99% pure gold. The refinery at the Barrick Cortez gold mine pours an average total of 1 million ounces of gold per year.
So after all the hard work we've seen, the engineering, the digging, the hauling, the crushing, the refining, this is the final product. This is called a doré bar, and it's about 700 ounces of gold. It weighs about 65 pounds. You're looking at about $6 million worth of gold right here.
But before we wrap up the show, we have one question left unanswered. What do they do with all the dirt they move that wasn't ore? That's where the environmental department jumps in. Their role in the world of modern mining is of great importance, since the protection of the land, air, and water where mining takes place is more important than the gold they produce. Everything from reclamation to the dewatering activities that take place are carefully planned and monitored.
The engineers design all of the waste rock dumps, which is what we're standing on right now, and We try to contour the waste rock dumps into native topography so that it looks natural.
Right.
Right now it doesn't look natural because we're dumping on it, but after they're done dumping, we come back in with growth media.
What's
Usually,
growth media?
it can either be alluvium that's harvested during the mining process, or it could be topsoil that was scraped before we started digging. We spread that and then we plant over it. And
Do you shoot it with fertilizer or water or anything, or does it usually do okay without all of that?
it depends. Sometimes we hydro seed, which we mix the seed and the mulch and spray it on with water, or a lot of what we do is broadcast and harrow, and it's especially useful on the waste rock dumps because they're a lot steeper.
And what does that mean?
So we'll come out and we'll rip the ground and we'll broadcast the seed, and then we'll drag over it to get that seed soil contact. We do concurrent reclamation, so we reclaim areas as they are finished. A lot of the waste rock dumps we reclaim within a week.
Really?
Yeah, after it's all said and done, usually mine ops gets the growth media on the surface, and then the seeding and ripping usually they can get done in about a week. It helps with soil stability, and it keeps noxious weeds out of the area also. And it benefits wildlife and insects and all the critters out here. So.
This has been an amazing trip. The best thing about this week has been the people I've met here at Cortez. There's absolutely no doubt. They are friendly, they are professional, they are funny, they are concerned with my safety. They were knocked out by how interested I was in what they were doing, and I was knocked out by the scope and the enormity of what they were doing, but the absolute humanity and safety that went into everything that happened on the ground there. I had a great week.